Hey everybody. I'm going to go over assignment 4 for the CS135 class. And once again, we're going to go back to this airport simulator, I guess, if you will. And we're going to compute, of course, Euclidean distance, Manhattan distance, and slope. The same stuff, we did in our earlier assignments, but we're going to sort of add on to it from the older assignments. So I think one definitely challenging part is going to be this concept of command line arguments. That's something we haven't really learned quite yet. So I will spend definitely some time talking about how to handle command line arguments, and then also go through the output and sort of try to maybe write a little bit of code to help you get started on the assignment. So I'm going to go sort of I guess you can read through problem. I'm not going to, this is like a lot of stuff to read here, so I'm going to go ahead and skip past all this. I'm just going to just, not really skip too much. So the first part here is just basically how to handle command line arguments. This is going to be a way of telling your program whether you want to compute Manhattan distance or if you want to compute Euclidean distance. So this argument will give you that. And also it's going to also pass into the program how many, sort of simulations, how many airports distances do you want to compute, basically. So for our command line argument, it's going to first give us, do you want the Manhattan or do you want Euclidean distance? And also it's going to pass in how many airports do you want to work with. Now, for this program, I believe over here in the, let me see, where does it have this? Here we go. So in this part, basically, for the first argument, it's going to be a dash m or a dash e, where dash m stands for Manhattan distance, dash e stands for Euclidean distance. And the other argument will be a number between 2 to 5, which means that your program is going to actually compute Euclidean distances of several airports between 2 to 5. So the first issue is, how do we actually read in command line arguments? So I think it's a good question. So let's go ahead and sort of work with this. So I'm going to go ahead and just pull up the program over here. It's an empty program. I wouldn't give you the entire worked out program. I would never do something like that to you guys. Don't even worry about that. I know you were scared for a second, but you can all feel calm about this. So let's go ahead and just sort of go into this a little bit here and just sort of try to understand how does this concept actually work. So I'm going to include IOStream, cstd lib. I'm going to need to use this, I believe. And I'm going to, of course, include this. Okay, this is always apparatus every program you write. We can't really do anything else. We have to always put those in our program. Okay, so you've always noticed that you had int main like this, and it was an empty set of left and right parentheses. So main is a function that takes in parameters. What's a function and parameters? Well, we'll learn about that later in the semester, but for right now, let's go ahead and discuss that. So to set up your program to be able to accept command line arguments, you have to give it some kind of parameters for int main. So here's a very standard way of doing this. So we're going to have int args, and then here's interesting here. So char star argv bracket. Yeah, that's pretty neat. Basically, argv is going to be array of strings. Now, what's an array? Well, we'll learn about that also later in the semester. And what are strings? Well, we kind of learned about that a little bit, not too much early in the semester. We did learn a little bit about strings. So a string number is just basically just going to be a set of characters, right? Just like a word, like hello world is a string. So just a set of characters, basically. So now I want to know, how do I actually handle this? Well, here's the first thing I'm going to do. I'm going to just simply see out args for right now. What will this give us? Let's try this out. So as always, we have our terminal always pointing to the folder in which we're working from. So this is actually already pointing to that folder. So I'm going to compile this program as always, g++ ps4, and it compiled. So I'm going to go ahead and run this and output 1. So args was 1. Okay, so how about the follow? Let's go ahead and run this again. So I'm actually going to make this a little bit wider, this terminal, because I want to be able to put more arguments in the command line. So a dot out, Then I'll say hi, bye. And now it gives me 3. If you can actually see that thing, I think it's seeable. So basically, this args tells you how many elements there are on the command line. So technically, this is one argument for a.out, and then hi, and then bye. These are each one argument. So basically, there are 3 arguments on the command line. So args tells us how many actual arguments you have on the command line. So that's kind of nice, we have that. So let's go ahead and actually worry about how do we actually extract these arguments out into our program. Well, we have this argv variable. So I'm going to go ahead and just maybe for now just see out. Let's say for right now I'm going to maybe use 3 arguments again. I'll use 3 once more. So I'll just kind of do this. So I'm going to go ahead and just say, well, cout argv 0 and L, cout argv 1 and L, cout argv 2 and L. Okay, let's go ahead and see what this does. Let's see what kind of result our program will get. So let's go ahead and recompile this program. I'm going to run this. And then we see the output. So argv0 gave us the output ./a.out. argv1 was hi, argv2 was bye. So this is actually an alternative way to feed sort of data into your program. So instead of having interactive, like cin, using a cin to read and stuff, this is an alternative way of doing it. It's not really always preferred. This is actually not good for interactive user input. It's more of just a way to kind of maybe you want to test a script or test a program out. Just want to feed input. You don't want to have to like really go through the whole interactive input like that. It might take too much time if you want to do many simulations of your program and whatnot. So there are some advantages of command line arguments, but anyway, that's kind of the gist of it. So okay, so that's great. So how do we actually incorporate this into our program? Well, in our program, remember, we had something like this. So we would have a.out -m, and then we had, let's say, 3. That would be a valid input, I believe. So if I run this, well, we get a.out -m and 3. So you can see the argv0 is really not very useful because it gives us ./a.out, and we don't really care about that. It's not going to give us anything important. But argv1 and argv2, those give us relevant info because we want to read in this -m. We want to also read in this 3, which means that we're going to do 3 sort of simulations. We're going to do 3 sets of inputs we're going to be reading in from the user. Because if you go to the let's go to the not the PDF but to the to this write up over here. Essentially, when you do this program, you're essentially passing in -m, sorry, and 2, which means you're going to do 2 sets of inputs. Here's the first one. Let's see where it's actually, looks like it's taking forever. There's a lot of cases. Here's the first input set. So we had all these inputs, but remember, they kept reprompting the user because they entered invalid values here. But that was one set of inputs. And then we had our second set of inputs, and then our output associated with it. So this number here tells us how many simulations of this airport we're going to actually do. So, okay, so the one problem is we're going to read in some number, but the issue here is everything read into a argv is going to be a string, not going to be an integer. So what I could do right now is I can convert this into an integer. So I'm going to take the cout statements out because we already kind of have an idea of how this works. So we're not going to really have to go too much in depth with this, just sort of know how to do sort of this scenario. So I'm going to, for right now, just say I'm going to create a string variable here. I'm going to say a string sort of, I guess, I'm trying to think of a good name to give for this. I guess I will call this maybe type, like whether it's going to be Euclidean distance or it's going to be Manhattan. So what type of distance we're going to calculate, I guess. That's a good enough. I think it's a good enough variable name. Also, I'll include string as well just to be safe. So let's include string. And then I'm going to have another variable, int. I'm going to call this maybe iterations. I'll call it. So this is going to basically tell us how many iterations we're going to do. Remember, this number will be between 2 and 5. Now, you don't want to hard code this, as in if let's say the user enters 3, you don't want to copy and paste that input 3 times. You want to have a loop that runs 3 times, because remember, we want to make sure our code is always scalable. So if we have it where we literally hard code and copy and paste 3, sets of inputs like that, well, then it's really not a good, I mean, it'll work, but it's not a good. It's not going to work for anything. So it's not going to be easy to up this. Say in the future, maybe have a different assignment later on, which maybe they could have 20 input sets could be read in. Well, then now you have to copy your code 20 times, and it becomes kind of a big mess. So you want to avoid that. So the first thing we'll do is we'll say type equals argv1. So we're going to load this into our variable like that, and then we're going to take iterations, and we're going to do the following. Here we're going to say a to I argv2. So this idea is that, well, argv2, let's say if it's a number. Remember how I could have put 3 here. The problem is argv2 is not going to be an integer. It's going to be a string that contains a number. So a to I converts a string to a number. So for example, of argv2, so argv2, I'm going to go ahead and put a little comment here. Argv2, it actually could be, let's say, like 3. But it's a string that contains 3. It's not the actual number 3. So this is going to return and assign iterations to the numerical equivalent of this string. So now we have these 2 parts in our program. So of course you have to check a few things. Well, we have to check, well, if, before we even do anything here, we gotta first check the following. So I think they gave this to you in the handout. We first check that if args is not equal to 3, then we have an error. That means, so it's basically the case like over here where for the sample output, this was actually 2. This was actually 4. So we had, so basically if args is not equal to 3, then we already know this program is already faulty. It's not going to work. So we have to exit the program immediately. Remember how that works? We just, return 0 or exit, we call exit the function, whatever we want to do. We want to end the program right here. So now, if let's say we know we have 3 arguments, okay, let's go ahead and load those into these variables. Now we know the type, and we know we have the iterations. So we check the value of type. Well, I'm going to go ahead, maybe give you a little bit of a skeleton type code over here for this. So I would say if type equals dash m, well, then we're going to be doing the Manhattan distance content. So we're going to be doing the Manhattan distance type of work. And then else if type equals dash e, then we're going to be doing the Euclidean distance. So Euclidean, I hope I spelled that correctly, like that. And then else, well, if it's else, that means you have another error again, because the first argument after a.out was not dash m or dash e, which is an invalid sort of argument to pass into your program. So notice in the test output over here, they have the case like this: .out, and then they have dash w. Well, that's not dash m or dash e, so the else case would catch that error. So you would give an error over here. Okay, so we have this part set up. So now, well, of course, I'm gonna maybe have some more variables. You might also have this. So I think the input right now are going to be all integers, I believe. So you're going to have, int x1, x2, and, all of that other stuff. Now, you wouldn't literally write it with dots. I don't want to write the whole thing out, but you can kind of see the pattern here. So you declare all your variables, all your x and y values up there just like that. So all your variables, you're going to need to put them up there, of course. So now, inside of each of these if statements, you're going to have a loop. And the loop is going to run iterations number of times. But of course, you have to make sure, what if iterations is not a number? And also, what if it's, not between 2 and 5? Well, a to y returns the value 0. It's not assigned 0 into iterations if argv2 is not a number. Otherwise, it'll store an actual number in here, and we can simply check inside if statements here to make sure that, well, is iterations is that number between 2 and 5. So that you can kind of do that yourself. I'm not going to really help you with that. But of course, in this loop, in this if statement here, we're going to loop through. So we're going to basically do the following. So I'll just do maybe the Manhattan one for right now, just to kind of help you out. So remember this for loop example from earlier today. We're going to run this many times. So this is going to run iterations number of times. And here you're going to, of course, you're going to read the input. You're going to, prompt for input and, calculate the, slope and distance, or in this case, and Manhattan distance and all that. And also, you may have to also loop inside here as well. So for example, when we read a value, you would have to reprompt on input failure, which, I mean, it could be a case where if let's say a cin.fail happens, or let's say if the value read in is not within range. So I believe on the handout here, I think they give us, yes, that it has to be basically in its range. It has to be, if it's less than 0 or greater than 100, that would be considered an error. So you have to check for that. But you're going to reprompt if the input is not valid. So I did write some code in a video earlier today that had some code of how to reprompt on input failure. So go ahead and look at that code and get a little idea on that. But you're going to have potentially a loop inside of this loop. So yeah, we're going to have nested loops also going on here. So you're going to have a loop here. So when we read in a value, you have to have a while statement that will keep on asking the user again and again until finally they enter a valid input. And for every x1, y1, x2, y2, you have to have that loop right after that to basically reprompt for each input. So you want to make sure that all the inputs are valid. And then you calculate all your results and you output the results within this sort of body right here. So you're going to output the results over here. Actually, no, you're going to output at the very end. Sorry about that. You're going to output at the very end of each iteration. So you're going to output the results right here. So basically, we're reading all of our values. So not read a value, but read a value and reprompt on failure. But you're going to be doing this. You're going to do this 4 times for x1, y1, x2, y2. And then you go ahead and actually here it puts calculate the slope. So I made a mistake with this comment. Sorry about that. But there's that. So that's going to be sort of the apparatus and the work inside here. Now, the last part to this program is going to be you want to output the highest slope and the lowest slope. So you want to have maybe a couple of extra variables that just hold the highest slope value and also stores their respective x values. So you may have to have another set of x1, y1, x2, y2 to kind of store those values into a variable, so you always know which x and y values yielded this slope. And of course, it's not too hard to do this, because obviously when you first calculate your slope, that's going to be your highest slope, and also it's going to be a lowest slope at the same time. And then when you start calculating new slopes, so when you go through this iteration over here, you're going to calculate a new slope every single time. So you're going to compare this newly calculated slope to a variable that already has the highest slope, calculated so far. And if this new one is bigger than the one you calculated so far, then you're going to assign this slope that you recently calculated into that variable that stores the max slope read. And you do this after every time you calculate a new slope. You compare it to, so I'll put this over here to, you compare to the old one. So compare to the old max and min slope. So that's basically the idea. And when you output stuff, you have to use io_manip once again. So you see here nicely aligned. So we can think of it as you have multiple columns. You have 1, 2, 3, 4, 5, 6 columns of output. You're gonna have two. You're gonna have first row will be just the heading, and the second row will be the actual values. You do the same thing for the other ones. So you basically do this mostly at the very end. So you output this. You're going to output sort of the min and max, or like the you output the min and max slope at this point, because once you finished up all your iterations, basically you actually went through all of the input. So here you only kind of do it for each input set. But over here, this is when you finally finish, you processed all the inputs. So now you're going to have your min and max slope here. So this might not have been too much information. Hopefully it was enough to help you. I can't give away too much more, but this is basically kind of like a little rundown, essentially, as to how to approach the assignment. So I hope this 20-minute video did help. And if you have any issues, of course, you can let me know. You can always ask me questions on Discord, along with the graders as well. But I guess that'll be just the end of this little talk over here. So I guess take it easy, and I guess have fun coding the assignment, guys.